back with a very interesting topic today on artificial intelligence security and LLMs. LLMs are algorithms that accept inputs via a chat interface, processes the input, and returns the response by predicting word sequences. The chat interface that accepts input is called a prompt, and from a security point of view is usually controlled by input validation rules. The security of the interface really comes down to how solid the input validation is. The stronger the validation, the safer the interface. Let's understand a bit more about how LLMs work. LLMs are usually hosted by third-party providers. A website can enable these LLMs to use its specific features by describing local APIs the LLMs can access. For example, a chat support LLM for an e-commerce website might have access for managing users, orders, products, inventory, etc. Now, the workflow for connecting an LLM with the API can vary based on how the API is set up. In some cases, the LLM might need the user to call a separate function or an API to send its request. So here is a typical workflow. The client sends the user's prompt to the LLM. The LLM identifies that a function call is needed and returns an object, usually a JSON object, with arguments that should be supplied to the function. The client uses these arguments to call the function. The client processes the function's response, and the client sends this response back to the LLM as a follow-up message. The LLM then uses the function's response to call the external API. Finally, the LLM summarizes the results from the API call and presents them to the user. This process can raise security concerns as the LLM may be calling external APIs on the user's behalf without them knowing. Ideally, users should confirm before any external API call is made. Now that we know this, how does LLM attack or a prompt injection even happen in a real-world scenario? Before diving in further, let me introduce a new term. It's excessive agency. Excessive agency happens when an LLM has access to sensitive APIs and can be tricked into using them in unsafe ways. This lets attackers push the LLM to do things it wasn't meant to do and potentially exploit those APIs for malicious purposes. To figure out which APIs and plugins the LLMs can access, the first step is to simply ask it. You can then dig deeper and ask for more details about any APIs that catch your interest. Let's look at this with an example. Here is an example of an LLM interaction where an injection attack can be exploited. I'm going to ask the LLM what API it has access to. That brings out 3 APIs with clear description of what each API does. Now I'm going to ask what arguments the debug SQL function or API takes. And here is the response. Look at that. The API takes a complete SQL statement and executes it. Now, as an attacker, I would assume the database that the LLM interacts with would have a users table, and I would supply the below statement. And it clearly brings sensitive data from the database. The difference here is that in a traditional SQL injection attack, you supply inputs or string values or even SQL commands, in some cases to the application input fields, whereas in an LLM scenario, you can provide all of those malicious inputs into a chatbot to extract information and follow the responses from the LLM to advance your attack.